Welcome to Invested in Climate. Protecting the planet and decarbonizing the global economy is the challenge of our time. We all have a role to play, and the opportunity we face is unprecedented. Invested in Climate aims to help people do more to address climate change through their work, investments, lifestyle, and activism. I'm your host, Jason Rissman. I support a growing community of top climate and ESG leaders as the Chief Experience Officer at Nationswell, and I'm an advisor to the climate practice at IDEO. I'm also an investor and startup advisor, and when it comes to climate action, I know I'll be a lifelong learner, always looking to have more impact. If you like what you hear, give us a good rating on Apple, Spotify, or wherever you found us. Sign up for updates and suggest ideas for future episodes at investedinclimate.com. Follow us on social, subscribe, and spread the word. Thanks for joining.
We are totally dependent on fossil. And I look at what I'm wearing, I'm kind of dripping in fossil carbon. I've got synthetic fibers and lycra and whatever it is in my clothes. This all comes from fossil today. So it's all very well thinking that, yeah, we can have solar and wind and renewables for electricity, but you still need a source of carbon for stuff. Not just for fuels for aviation, for example, but for the chemicals in the materials we use every day, packaging, textiles, plastics. Today, that all comes from fossil carbon. And so why we say you should reuse this carbon or these emissions that exist today is because we want to stop extracting more carbon. And we call this a circular carbon economy.
Hey, everyone. Fossil carbon is not just burnt for energy, it's also used as an ingredient for millions of everyday products. But what if, rather than extracting new fossil carbon from the ground, the carbon could be sourced from waste and kept in circulation? That's exactly what a company called LanzaTech is doing. For almost 2 decades, LanzaTech has been using a synthetic biology process to recycle carbon waste and create new products. They went public earlier this year, and to me provide a fascinating example of a climate tech company with a bold vision for transforming how our material world is actually built. That's why they were recently recognized as a finalist for the prestigious EarthShot prize. In this episode, I'm joined by LanzaTech's Chief Sustainability Officer, Freya Burton, and Chief Science Officer, Zara. We talk about the growth and evolution of LanzaTech, their effort to create a circular economy of carbon, their technology, partners, and much more. This episode will push your thinking in some really interesting ways. Enjoy. Freya and Zara, welcome to Invested in Climate. Thanks so much for being here today.
Thanks. Thank you for having us.
Excited to be here.
Great. Zara, it was great seeing you at a Nationswell dinner a few weeks ago in Chicago. That was quite a group, and I'm glad you were able to be part of it. Freya, are you in London at the moment, and how's your summer been?
I am in the UK, yes, and it's wet and miserable in the UK, so a perfect summer for us.
Well,
very normal. Yeah.
Very normal. Great. Well, as we traded notes, we'll both see each other at Climate Week, so I'm sure you'll get some sunshine in New York soon enough. Let's get started by learning a bit about both of you, your backgrounds, and what you were doing before you got involved with LanzaTech. Freya, would you like to kick us off?
Sure. I've been at LanzaTech for quite a long time, so I almost can't remember what I was doing before, but by background, I'm a biologist, and I happened to meet the founder or co-founder of the company, Sean Simpson, back in about 2006 in New Zealand, where I was living at the time. I knew him personally. I used to work with his wife, and he said one weekend at a party, he goes, I've got an idea for a company and I'm looking for people to work there. Do you want to join? And I thought, why not? Let's see where this takes us. It probably won't last. Fast forward 17 years and I'm still at LanzaTech. So I started as a research associate in the lab and worked pretty much in typical startup mode in every job that needed to get done before we could afford to actually pay someone qualified to do it. I've stuck at a number of roles, namely government relations and external relations. So from the lab to facing the outside world has been my journey at LanzaTech.
Incredible. Well, we don't talk to too many people that have a 17-year tenure at a climate tech company, particularly one working on advanced technology like you all. So excited to hear more about that history. Over to you, Zara. What about you? Tell us a bit about your history.
I am a microbiologist by training. After grad school, I thought I would go into academia and teach other people how to love microbes like I do. I've always worked in environmental microbiology, looking at the unique metabolisms that exist in the world. Most of my career has been spent on things that don't breathe oxygen, so I've had to go really deep underground to find them. So I joined ExxonMobil after my career kind of took a right turn and ended up at ExxonMobil and was there for about a decade, building and leading their biosciences group. So we covered everything from biofuels to biochemicals. And having such a large company backing that was really exciting. It was like a small startup within a large corporation, but it wasn't moving fast enough. And I didn't see impact that we could tangibly feel around us. And so when I got introduced to LanzaTech, I called up Jennifer and Sean. I said, you need me. I'll take any job. I just want to do something that's real. So I went from an oil company to a climate tech company, and I haven't looked back. So it's been great. Wonderful.
We won't let her look back. She's
amazing. Fantastic. Well, we could probably do a completely separate episode around your tenure in the oil industry and what you learned. But let's dive into LanzaTech. Freya, you are LanzaTech's Chief Sustainability Officer. And as you've mentioned, you've been with the company for 17 years. Tell us a bit about LanzaTech's founding and why it was founded. Really, what's the problem that you've been working to solve?
LanzaTech was started on the premise that we needed to find an alternative to oil to make all the things that we use every day. And we started by focusing on fuels and looking at what alternatives existed at the time. And primarily that was corn, ethanol as for road fuels. And the two co-founders, Sean Simpson and Richard Forster, they were working at a company at the time that was looking at using biomass to make, so plants, to make fuels. And the technology didn't work. And really together, they said, look, we need a feedstock that's abundant, available, low cost. If it's a waste, that would be great. That's point sourced, so we don't need a lot of infrastructure to grow and harvest and move it around. And they hit upon the idea of using waste carbon in the form of pollution, because there's a lot of it. It's a problem, but it has all the constituent parts that you need to make stuff, namely the carbon. That was really the genesis of LanzaTech, was trying to find a feedstock that could work to solve this really big problem, which is how do you stop extracting more fossil from the ground? And how do you stop pollution from going into the atmosphere on this kind of one-way street of carbon? We extract, we use, we emit. And LanzaTech was formed to break away from that way of using carbon.
Thank you, Freya. That overview is really helpful, but it also raises some questions in my mind. You've described the genesis of LanzaTech as seeking feedstocks for everyday products and seeking feedstocks that come from waste rather than fossil carbon. So what you're doing really is transforming emitted carbon pollution. And it begs the question, rather than finding stuff to do with emissions, shouldn't those emissions actually just be eliminated?
Absolutely. The future is, we like to sort of talk about what we call a post-pollution future, where this isn't a problem anymore, but that's not happening today. And there are emissions going out into our atmosphere. And the reason that happens is because we have this very linear carbon economy. What we're trying to do is say, look, there is no perfect solution out there. We need all solutions to start abating carbon. But it's not just about the carbon that goes into the atmosphere. We need to look kind of downstream and say, well, what are we going to do with that carbon? And a really big part of this is, how do we wean ourselves off our fossil habit? We are totally dependent on fossil. And I look at what I'm wearing, I'm kind of dripping in fossil carbon. I've got synthetic fibers and lycra and whatever it is in my clothes. This all comes from fossil today. So it's all very well thinking that, yeah, we can have solar and wind and renewables for electricity, but you still need a source of carbon for stuff, not just for fuels for aviation, for example, but for the chemicals in the materials we use every day, packaging, textiles, plastics. Today, that all comes from fossil carbon. And so why we say you should reuse this carbon or these emissions that exist today is because we want to stop extracting more carbon. And we call this a circular carbon economy. Now, of course, if you're making consumer goods, some of them will, when they reach the end of their useful life, it will be a waste carbon again. But we start thinking, well, how do we avoid that waste? What can we do with trash, as an example? So we've developed technology that can take mixed trash that doesn't have to be sorted or doesn't need the mechanical recycling, which we all know there's not that much infrastructure for mechanical recycling right now. And we can turn the carbon in that trash into materials again through a process of our technology, which Zara will talk about, gas fermentation. So really what we're trying to do is move it from linear carbon to circular carbon. When we move to a future where there is no more carbon being emitted, we can use other sources of carbon from biomass waste, agricultural waste, even carbon that comes out of natural fermentation processes. We know today, for example, corn ethanol. It's producing CO2, and we can use that as well. So it's not limited to polluting industries. It's very flexible. But the whole point is keep carbon in a material chain and don't let it go out.
Wow, Freya, that's a really big vision. I've heard talk of a circular economy of carbon, but you've described it in really clear and helpful terms. And it suggests to me that this is a really big opportunity. As Chief Sustainability Officer, you're surely tracking and thinking about the overall environmental impact. Give us a sense of the scale that you're targeting.
We're talking gigaton scale. This is game changing because if you can prevent emissions from going out and you can displace fossil carbon from coming up, you can have a really significant impact. If you can use CO2 as a feedstock, which is the kind of holy grail, there's a lot of CO2 in our atmosphere. If we can capture that and use it, it's limitless. I couldn't put a number on it. But what are we doing today? We've got a pathway to gigaton carbon abatement. By the end of this year, we'll be abating about 500,000 tons of CO2 a year because we expect to have 6 plants operating, which are taking industrial emissions to make ethanol, which we then convert into other materials. And a good example is that ethanol can be turned into things like the building blocks to make PET, which we know in polyester fibers or packaging. It can also be used in really practical things like household cleaner and fancy things like perfume. We can start reusing that carbon into things that we use in our lives, and we don't have to be extracting that fossil carbon. I actually had someone do a back of the envelope calculation recently where they said, so today our 3 operating plants have abated the equivalent of about almost 300,000 tons of CO2 equivalent. And they said, oh, that's about, and they did a little calculation, it's about the emissions equivalent of charging 30 billion cell phones. So I haven't verified all of that. It's not a very scientific calculation. I don't have all the numbers behind it right next to me. But the idea is think about how much energy there is and what we could really be displacing. And then the future, as I said, it's limitless when you can harness all of that carbon that we have this imbalance of carbon in the atmosphere and we could just use it instead of taking more out of the ground.
Fantastic. Zara, as the Chief Science Officer, you're probably well equipped to help us understand how this works. Will you tell us a bit about the technology?
As a microbiologist, I'll set the scene by saying we have to go back about 3.7 billion years ago when the first microbial life evolved on Earth. The Earth at that time had no oxygen in the atmosphere. So this was maybe 1.5 billion years later, the great oxygenation event happened, right? So for about the first 1.5 billion years of life on Earth, there was no oxygen and there was a lot of reduced gases. So hydrogen, carbon monoxide, CO2, methane were all present and abundant in early Earth. So pathways and metabolisms of microbial life were dependent on those sources as the carbon source and energy source for creating life. If you fast forward 3.7 billion years today, we use a unique bacteria that uses reduced gases. So this is an ancient metabolism that we're leveraging to convert gases such as CO2, carbon monoxide, hydrogen, to products like ethanol. Those products then can get taken to fancy perfumes and running shoes and yoga pants. Harnessing what life on Earth already does really well, specifically the microbial world, is I think one of the best approaches one can take, because that's 3.7 billion years of evolution to really hone in on an efficient use of things we see as waste emissions today an organism's entire life is dependent on these reduced gases to build everything it needs, from carbohydrates to lipids, DNA, all of it is built from these gases. What we do is we take this organism, it's a Clostridium species, we put it in a very fancy bioreactor, and we say, here's a ton of gas, it goes through the bioreactor, and out comes wonderful, happy cells and ethanol. Through the power, if we think about the biological revolution that's happened in the last 10 to 15 years, what's been amazing is the ability to take DNA and edit it. What we can do now is, while we make ethanol in our commercial plants today, so gases come in, ethanol and cells come out, we sell those cells as a protein source for aquaculture, so we can feed fish with that, very sustainable, high protein diet. The ethanol goes on to make wonderful cocktail dresses. But what we can do is engineer our organism through synthetic biology tools and create things that will blow your mind. So we've made over 100 different molecules with our organism through genetic engineering. And what's really exciting there is you can imagine a world where we have one bioreactor and you drain it and put a new strain in it and you're making a different product. So gone are the days of thinking oil and gas where you have a huge refining complex where each huge piece of steel makes one product. Now you have gas into a bioreactor, and that bioreactor you can drain and fill up with a new strain and make a new product. It's just an exciting future that we're unlocking thanks to tools that are evolving around us. It's a really exciting time to be a scientist, to be honest.
It sounds like it, and fascinating, all the things that you can do with it. Let's rewind for just a second just to clarify, where are the gases that you're capturing coming from? And I think that points to, who are you partnering with to help remove the carbon emissions or other types of emissions that then in some ways is a feedstock for you?
We sit kind of between two industries. On one side, you have a steel mill or an oil and gas refinery that's producing these gases as a result of their normal operations. So you have furnaces, you have different refinery units that have a high amount of reduced gases coming out in their stacks. We can divert that into our bioreactor. So we work with, like I said, steel mills, ferroalloy production facilities, oil and gas refineries. We can even take CO2 from direct air capture. We can take hydrogen from an electrolyzer. We're not just working with heavy industry. We can enable making high quality products for humanity from CO2 and hydrogen, for example. So we can capture it from the atmosphere and mix that with green hydrogen and make a very sustainable product. We can also take waste or residual biomass that exists in the world today, and we can gasify that. We can, instead of combusting it, you turn it into gas. And we can use that as a feedstock. So that's also a really sustainable path to making products. And we can even take unsorted municipal solid waste as a feedstock, so that you can also gasify. So one day you're taking garbage bags from houses. The next day you're taking construction waste from the demolition of a building, and so on and so forth. So really unsorted waste is very challenged. And I think Freya mentioned this circular economy. If it has carbon in it, you can turn it into a gas and you can feed our system. So the diversity of things that are the feedstock is one of the things that's so exciting. And then if you think about the diversity of things that we can make, ethanol is a building block molecule. It can go from jet fuel to diesel to polyester, polypropylene, polyethylene. And then once we add on new strains, you can make a whole bunch of other things from there. So really, we're this centralized piece that connects heavy emissions or sustainable gas sources to the consumer industry that is clamoring, that is demanding, that is pleading for sustainable products. We're able to provide those solutions across a lot of different, from fuels to chemicals to fancy Gucci perfume.
Very cool. Zara, as we mentioned, LanzaTech has been around for almost 2 decades. How has the technology evolved over the years, and what would you say is the hardest part?
Well, I think as with anything, we're always looking externally to what tools are being developed. We do work with a unique organism, so we have also had to develop our own tools to understand and to work with it. So for example, when the company was started, we were able to very quickly move to industry relevant gases. So steel mill gases were very quickly introduced into the process to ensure our organism was robust. Understanding all of the inner workings of this organism did take longer because tools weren't necessarily available, but as DNA sequencing, as RNA sequencing, as a lot of molecular biology tools evolved into massive data creating paths, we were able to then go back and look at why is our organism happy under some conditions and perhaps not others. And so I think what's advanced most is the levers that we've introduced in order to tune our organism to make a new product, survive in a different environment, or to make something completely different. The other thing that's evolved is our reactor design. So we were one of the first companies to commercialize gas fermentation. We are the first. And with that, every plant we design is improving because the more we learn about the process from our organism and from an engineering perspective, the faster we can make tiny bubbles and the faster we can separate products. And so really, we are lifelong learners and we're constantly looking for improvements.
And Zara, I know that from our dinner together, artificial intelligence is on your mind a great deal. How is AI involved in your approach?
I think AI is going to be critical in helping us look to the future and leverage our data. AI is going to enable taking 18 years of fermentation data and digesting it in new ways, understanding new ways, and even making connections that maybe we haven't made before. I think one of our huge advantages is the amount of data we've amassed over this time. We've done a really great job as a company in organizing that data. And that's the biggest hurdle. When you want to leverage AI, it's how solid is your data set and how organized is it? Because if you want to train a model, if you want to make connections, you need that really well-organized data set. And so we are uniquely positioned to have both commercial data and lab data that really is going to enable us to unlock all sorts of new learnings based on historic data alone. Without running a single additional experiment in the lab, there are new things we will learn based on models that you can create using AI and machine learning. Even if I look back what we were doing 2 years ago, the amount of machine learning that we have introduced to our day-to-day work processes has grown orders of magnitude. And it's making our researchers more efficient. It's allowing them to digest data that's historic, and it's really unlocking and opening new doors for us every single day.
Thank you, Zara. Freya, let's come back to you. I know that you've described LanzaTech as a carbon transformation company, and that's different than carbon capture. And you've also made a really compelling case around the perhaps limitless places where we can replace fossil carbon with synthetic bio-created carbon. So where do you start? Who are your current customers? And what kinds of companies are you working with? And what kind of partners are you looking for today?
We talk about carbon transformation or carbon recycling because we're not just capturing it and doing nothing with it or burying it. We are actually making something with it. So giving it a value, taking that waste and creating value. And that's a really important part because just to set the framework of this is carbon capture and utilization or transformation often doesn't get as much airtime as something like sequestration, burying carbon. Not in the policy space. Normal people might not know that these types of technologies exist. I sometimes joke, I feel like a bit of a preacher because I'm saying, look, you can reuse carbon, spread the good word, utilization or transformation of carbon is possible. We've been really lucky to work with partners who see this future, who understand that you don't need to be extracting more carbon out of the ground. And a lot of partners we work with don't want to use food-based or crop-based feedstocks. So an example would be those who need ethanol as a feedstock for either fragrances or home care products. Today, they might have ethanol that comes from crop-based feedstocks. And they want to move away from that because of the impact on land and water and biodiversity. And if you think about all of the carbon that we need to replace to keep fossil in the ground, we really can't use all the biomass, all the trees and all the plants and crops to do that. So we're partnered with companies who really see the future as being one sort of based on recycled carbon from a number of resources, but in particular from waste carbon. It speaks volumes that the first 100% fragrance using recycled steel mill emission derived ethanol was the House of Gucci. I mean, they had an exclusive fragrance that came out earlier this year, and there was no yuck factor. It was heralded as an awesome thing. It still had a pretty awesome price tag, but it smelled amazing. It doesn't come off the steel mill smelling like that. But this was a high-end product. But it doesn't mean that we only work with niche products only for those who can afford it. We're also making laundry detergent or household cleaners that go into generic brand ranges of supermarkets. And our customers are those who don't want to put a price premium on it because they believe that sustainability is for everybody. There is still a price premium because you can't compete with fossil today, but then it's not really a fair comparison because new technologies are expensive. They're getting down the cost curve and they don't have all those years of incentives that the fossil industry has got. So it is challenging, but the partners we work with, for example, Lululemon or ArcelorMittal at the sort of the emissions side, even groups like Coty, who sort of the umbrella cosmetics company for Gucci fragrances, for example, they all have this vision of a future where we can use these feedstocks. And that's created really strong, long-lasting partnerships for us.
Freya, in some ways, you really have your finger on the pulse of two sides of the marketplace. And I'm curious how they compare in terms of maturity and awareness. Is demand for products made with transformed carbon keeping up with the amount of carbon that you're transforming?
No, not yet. I think consumer awareness is getting there. And I think it's really helped by the fact that there's some really cool labeling and some of the products that we've made with Zara, for example, Zara, yes, with Zara here, but also the company Zara, they have cool labels where who would have thought like a party dress at Zara would explain a process of taking steel mill emissions to make a chemical called monoethylene glycol. I mean, who would have, and would that resonate with a consumer buying a cocktail dress from Zara? Well, it did. This is, I'd say, niche audiences who were interested in that, more probably from a coolness perspective, but also cool climate tech is getting a lot of traction. All of the ranges that we've launched have sold out really quickly. There is definitely a desire for it. Is it mainstream? I generally ask myself, does my mum know about it? And while she'd know about it from me, just generally speaking, if she can't see it in the shops or it's like in whatever she's reading, it's not as mainstream as we'd like. So I joked earlier about spreading the good word, but this is kind of what we need to do. We need everyone to kind of question where their carbon comes from. And it's a big mind shift where people might have thought about things like organic or fair trade or even behavioral shifts like throwing garbage on the street, not in the garbage can. It's just starting to think about how we consume and dispose of things in a different way. I would say on the upstream side, industry is all over this. There is a lot of demand. There are limited solutions, but more than ever, solutions are starting to deploy, and we need all of them because this is a really big problem. So we are part of the solution. We're a pretty awesome solution, but there are also other ones, and industry they're investing. People are all over this. It's existential for them. They need to find new ways of doing business, and it's a great time to be in climate tech.
Let's go deeper into that. Who is it existential for exactly, and why do you say it's that critical?
Look at big industry, heavy industry like the steel industry. They need to find ways to reduce their emissions. In a lot of countries, they have a high price on carbon and they have emissions obligations, so emissions reductions obligations. So that's a cost center. That carbon that's being emitted is a cost. Well, why not turn it from a cost into a profit center? So it makes economic sense. They're not all doing this out of the goodness of their hearts, although they have a lot of targets now more than ever for reducing emissions. But it has to also make economic sense. These are big industries. They have big emissions profiles, and they want to start making improvements to that bottom line, but they also want to start thinking about the future. The other industry, and Zara mentioned, we can turn ethanol into aviation fuel. It's existential for the airlines. They have a lot of commitments to meet. Unfortunately, today, the amount of sustainable aviation fuel being produced is less than 1% of what we need to replace from fossil jet. They are doing everything they can to invest in solutions to get more volumes of sustainable fuels into the market because they have to. In a lot of countries, there are mandates to include that and to reduce emissions and so on. And I think consumer demand is heading that way as well.
Let's go deeper into the aviation side, and Zara will bring you back in here. I know the company previously spun off LanzaJet, which perhaps could be a topic of an entirely separate episode, but be curious really briefly, how is LanzaJet going and how is it still connected to LanzaTech?
No, that's a great question. I think LanzaJet, it's a really exciting time right now because they're building their first 10 million gallon a year plant in Georgia, down south, about an hour and a half outside of Savannah. That plant is getting towards being complete and is hopefully going to be up and running in 2023, which is extremely exciting for all of us, both at LanzaTech and at LanzaJet. So as you mentioned, it was at one time a division within LanzaTech. We spun it out as a separate company. And what that really enables LanzaJet to do is take ethanol from anywhere, right? We are not the only ethanol producers today, and we have to enable a transition. I don't think anything to do with climate change is going to be answered by excluding anyone. This is, as Freya mentioned, an existential crisis that's hitting every individual, every company, everywhere, every country, every landscape. It's everywhere. It's our planet. We have one. It's warming and crazy stuff is happening. I don't know if you've watched the news lately. I think about how much climate change was mentioned in the news even 5 years ago. And then you think about today, it's daily. It's daily on a lot of different, well, at least the news I watch. When I think about LanzaJet, they are enabling a true transition. They are an inclusive company that's going to take ethanol from corn, from sugarcane, and from LanzaTech. Over time, we would like to be a major producer because we see applicability for what LanzaTech does so broadly. Like you can apply it to any industry that has emissions. But I think what LanzaJet is doing now is so exciting because they're not going to wait for us to produce enough ethanol to make 10 million gallons of jet fuel. They're going to make 10 millions of gallons of jet fuel now based on a lot of different sustainable ethanol sources.
Thanks, Zara. Something that Freya mentioned caught my ear, and that is that the carbon capture industry, and specifically taking carbon and burying it in the ground, gets all the love. It gets all the attention. And I'm really curious from a regulatory and policymaking perspective, has LanzaTech been able to benefit from some of the federal climate action here in the US or climate policies elsewhere? And what do you expect in the future? Will there be other policies that influence the carbon recycling space in ways that help the company?
Absolutely. And I think it's been really interesting with the Inflation Reduction Act in the US and how that's creating a really positive environment for both the sustainable aviation fuel space and also for carbon capture and utilization technologies. There's still a ways to go because, as I alluded, sequestration, they actually get greater benefits than utilization. So they get more money to bury carbon than we might to use it to make something useful. And that's not just limited to the US. It's a trend that we've seen in European legislation as well. We kind of joke that the acronym CCUS, carbon capture, utilization, and sequestration, the U is silent because it doesn't get any love. But it's starting to change, and there are now categories of fuels called recycled carbon fuels in Europe. But they often have to kind of jump through more hoops than any other type of fuel, certainly more than fossil fuels. It often feels like the regulatory landscape makes it hard for everyone trying to do something new. It's almost as if they're waiting for perfect solutions to the exclusion of solutions that are good enough to just get us going on this pathway. And as Zara said, we need everything and we need it now. And we're coming up to yet another COP where there'll be a lot of chat, but no progress. And we need to be putting steel in the ground today to even come close to meeting the 2030 targets. It's very hard to do that if you don't have a good market for the stuff you're making, because you can't get investors to move forward. And this is not about LanzaTech. This is just about mobilizing the investment to put steel in the ground to start getting those volumes, for example, of fuels for the aviation sector. That's what the problem is today with the regulatory space. There's positive steps, but it's not enough. No way near enough.
I agree. It's not enough, and we need to do more to move faster. We certainly need ambitious companies like yours going for the gigatons, and we definitely also need more policy urgency to accelerate progress. Freya, you and I actually met through an initiative with its own set of bold goals to change the narrative and accelerate global climate commitments. I'm, of course, talking about the EarthShot Prize, an annual £5 million prize launched by the Royal Foundation in the UK. LanzaTech was a finalist of the prize, and I'd love to hear about your experience. How has EarthShot been helpful to LanzaTech?
EarthShot was awesome. We were so delighted to be a finalist of the EarthShot Prize, and the visibility of EarthShot, and obviously with the Royal Foundation and the association with Prince William, really helped raise a lot of awareness in areas that we wouldn't have had exposure to previously. And that's why I think the prize really does bring it to more people, all these amazing types of technologies. And that's been phenomenal for LanzaTech. And there's a really great program for all the finalists, which is obviously where we met, which goes on for a year from when you're selected. And that's actually just come to an end. We had our sort of graduation ceremony last week. But throughout that process, there's a lot of mentorship and connections to other organizations who are willing to help because of this desire to move things forward and bring new solutions to market. So it's been a great experience.
Fantastic. I'm glad it was such a positive experience. Freya, I should also congratulate you as LanzaTech recently went public. I'm curious, what has that changed for the company?
There's a lot more lawyers involved now. I can speak for myself, having been with the organization from when there were 4 of us and we were kind of the scrappy little startup in New Zealand to now being this kind of grown up, having to deal with proper filings, and we have an earnings call coming up and there's a lot more official hoops to jump through. But it's really exciting for us because, again, there's visibility. It's given us opportunities to invest in a lot more in the organization. But obviously, we have a lot of scrutiny on us at all times. And just looking at the ticker numbers going up and down doesn't tell the whole story, unfortunately. But that's kind of how people make their investments. And we just hope more people learn about what we're doing and how this really is the future of a lot of things. I'm curious to hear what Zara thinks, because you've been in a public company as well, but this is a whole nother ballgame.
Thanks, Freya. I'd love to turn to Zara as well. And let's talk about the future. Obviously, as a public company, I know you can't make specific forward-looking statements about your company, but tell us about the industry more generally. And what do you think will be different 5 to 10 years in the future?
I came from a 140-year-old large behemoth public company, and now in a scrappy little public company. I think that's exactly right, Freya. I think what's exciting is that we're paving the way for others, saying it's okay, go for it. It's not pie, right? Climate is not pie. There's plenty of CO2 to go around. We need all solutions on deck. And I think when there's startup incubators, there's different groups that are on the cutting edge of new science, new technology out there. I think the more we normalize, hey, we're a climate solution, it's not all doom and gloom. There is hope. We are harbingers of hope. We bring hope. And when I look to the future, it's really exciting because anywhere I go, when I meet other companies in this space, it's not competition. It's a huge mountain we're going to all climb together. And maybe we get there first. Okay. But everybody else gets to get there too, right? It's not exclusion. I love how LanzaTech approaches inclusion, diversity, and equity. We live it every day. Our teams live it. How we hire lives it. How we treat our employees lives it. But also how we approach the problem. We are enabling people to see a future where you can still make revenue, but you can also decrease your emissions. That enablement, I think, is just so hopeful because it's not you have to stop operating. It's what if there was an alternative? We are that alternative. Let us help you get there on your journey. And let us show other companies, like we reach out to other small companies all the time through Freya's team, through interactions with societies we present at. And it really is that camaraderie and that fellowship that I just find so inspiring working here. I have a lot of hope.
Going more specifically into that, LanzaTech is obviously a pioneer and an early adopter, in some ways a leader, but you're seeing many others get into the space of using synthetic biology to transform carbon and create a circular economy of carbon. Is that right? So you envision hundreds of companies doing this in the future?
It's a whole new supply chain we're building. And what that is going to do is maybe not every company is doing everything, but as you build up an entire industry, niches and different areas will emerge as critical points along that journey. What we're doing is showing a whole new future that is going to create entire mini communities within that. It's just creating so much opportunity for people to bring innovations from biology, from engineering, from water treatment, from every type of different scientific discipline, as well as new marketing strategies. There's a whole psychology to help people view carbon, right? Decarbonize maybe isn't what we should be pushing today. Like, let's get into what do people actually mean when they say decarbonize, and what are people hearing when they hear decarbonize? They're thinking about the climate. But as Freya pointed out, we are covered in carbon. Our daily life is dependent on carbon. Carbon is one of the most abundant elements on Earth. We cannot get away from carbon, but we can better deliver carbon to people. We can treat carbon as precious. We can use it as a resource. We can stop pulling carbon out of the ground and pull it from the atmosphere. I think there's a lot of opportunity.
Zara, Freya, I love conversations that really push standard thinking, and this has certainly been one of those. And I'm sure for many listeners, it will be really inspiring and informative. Let's leave off with something also really actionable for them. Many listeners might not be in a position in which they're able to really engage with LanzaTech, but given the unique view that you have on climate, what's your call to action for our listeners?
I would always say you're never too small to make a difference. We started out as a small team. We're really changing the whole energy paradigm. And it started out with one idea. So my takeaway to people is people say, what can we do? It's like, you can make choices in your life. That's an action, and that's good because everybody collectively will make choices and that will move the needle. But think about how you're consuming. Think about where your dollar goes and what choices you make. Think about where your vote goes. These are things that we can't ignore anymore. And I think for a long time, we've kind of just gone, yeah, it will be fine. I'm guilty of that too sometimes. You kind of want to put your head in the sand. But I think a call to action is for people to really start thinking about it, because we've pretty much run out of time, but we can make meaningful change, and nobody is insignificant enough not to make change. You all can play a part in it. So don't give up hope, fight the good fight, and keep making changes where you can.
Thank you, Freya. Zara, over to you. Take us home.
I think Freya made really good points. I will add a little bit of weight to that, in that folks listening to this podcast have the luxury of making those choices. If you're on the fence about making climate positive choices, think of all the people in the developing world that don't have that choice to make, and take that responsibility on. We are all sharing the same atmosphere, the same planet. A lot of countries that are going to be most severely impacted by these extreme events, extreme weather events, flooding, those folks don't have the luxury of making choices. Their choices are much more focused on how to get them through the day, how to feed their families. So I think folks that have the luxury of having a device to listen to a podcast on should really be feeling that weight of, not only do you have those choices to make, but others do not. So that's even more incentive to make a good choice.
Freya, Zara, thank you so much for your time today. Best of luck with all that you're doing, and hope to see you both again soon. Thanks for joining us for this episode of Invested in Climate. Please remember to rate us on Apple, Spotify, or Google. Find show notes, sign up for updates, get in touch, and visualize your climate action at investedinclimate.com. This podcast is for informational and entertainment purposes only and does not constitute financial, accounting, or legal advice. Thanks again.